Welcome back, everybody. Today we are doing section 9.3, and 9.3 is solving quadratics. All right, so let's get going with our start thinking. Take a minute to think about this. How are equations different than functions? So how are equations different than functions? There's a couple of hints inside of the names, right? If we're looking at equations, and we're going to do equations over here, equations have to equal something. So with equations, they're set equal to 0 or set equal to something. Whereas with functions, right, we're looking more generally. So we were talking about linear functions or quadratic functions, right? We have to have y is equal to something. Now, functions are useful in a ton of different places, but what we do with equations is we always solve for x. So functions, y equals, equations, they're set equal to something, and then we're trying to solve. We're trying to figure out what they're equal to, or what value the variables take that will make the two sides equal. All right, let's get started looking at how this relates to quadratics, right? We're looking at quadratic equations. So a quadratic equation, our standard form, is going to be our quadratic ax squared plus bx plus c is equal to 0, right? And we're trying to figure out what values of x will make this true. So we have the solutions. The solutions to a quadratic are called a couple of different things. So we have solutions. They're also called, well, they're called solutions. Excuse me. They're called solutions. But we also have two other names for them. Call them zeros or roots as well. Let's start off with figuring out why they're called zeros. So, why are they called zeros? That has to do with when we're dealing with graphing. The solutions to a quadratic are the x-intercepts. Or where it crosses the x-axis. So, if we were looking at some quadratic, and it looks like this, then our solutions are the x-intercepts. Our solutions are going to be x is equal to 2, right? That's where it crosses here, and x is equal to negative 1. So, for zeros, right, they're called zeros because it's where your y values are 0. It's where you cross the x-intercept. Let's go through the steps for how we solve for something graphically. Step 1, we're going to want to get one side equal to 0. Step 2, change the 0 to a y. Step 3 is going to be graph. And step 4 is find your answers, which are the x-intercepts. So let's go through an example. Let's say we have something like 4 is equal to x squared. Step 1, get one of those sides equal to 0, so let's subtract 4 from there. We get x squared minus 4 is equal to 0. Step 2, change the 0 to a y, so we get x squared minus 4 is equal to y, or that's the same thing as y is equal to x squared minus 4. Our next step is to graph that. So let's do that. Our y-intercept is 4, and you can throw this into your graphing calculator. That's going to be the easiest way to do that. When you do that, what you'll see is we get point down there, and looks something like this. So, what are our x-intercepts? Well, our x-intercepts are right here and right here. So our solutions, or our answers, are x is equal to 2 and x is equal to negative 2. So that's solving by graphing, right? We're looking for the zeros. We're looking for the x-intercepts, and those will be our answers. Now we said these are called solutions, zeros, or roots. So let's look at why they're called roots. Why are these called roots? Well, you solve with the square root. So we take a root to find our answers. How do we do this? Well, step 1, we're going to want to isolate x squared. We want to get everything away from x squared. Step 2, we're going to square root to get rid of the square. And then step 3 is don't forget you have a plus or minus. So this is a super important one. Make sure you star this, circle it, do something to remember it. Let's go through an example for this. Let's say you have, again, the same one as we had before, x squared minus 4 is equal to 0. Step 1 is to isolate x squared to get everything to the other side. So we add 4, we get x squared is equal to 4. Step 2 is to take the square root. So we take the square root of x squared, and we get that square root of 4. Right? Square root and square will cancel out, so we're left with x. And x is equal to, don't forget, it's positive and negative. So what are the square roots of 4? What numbers multiply together to make 4? 2 and 2, but also negative 2 and negative 2. So our answer is x is equal to 2 and x is equal to negative 2. Or you'll see that written sometimes as x is equal to plus or minus 2. Now, square roots, or quadratics, excuse me, can have a couple of different solutions, or a different number of solutions, and that has to do with this square root that we see here. So let's go over the number of solutions. What happens when you take the square root of 9? What happens when you take the square root of 9? Well, what numbers multiply together to make 9? Or multiplied by itself? 3 times 3 makes 9, but also negative 3 times negative 3 makes 9, right? Negative times a negative makes a positive, so those would cancel out. Meaning that one of the options we have is we can have two solutions to a quadratic. Okay? What about if you take the square root of 0? What numbers multiply together multiplies by itself to make 0? Well, we get 0, and we can get negative 0. But that's the same thing as just 0, right? Positive 0 is, 0. Negative 0. Negative 1 times 0 is 0. So we can have the potential for there to be one solution. And what about if we're taking the square root of a negative number? What number times itself makes negative 1? Well, you might say positive 1 and negative 1, but right, those aren't the same number. Positive 1 and negative 1 makes negative 1, not the same number. Negative 1 times negative 1 makes positive 1. So we don't know. And the answer is there actually aren't any. So we can also have 0 solutions. And this can also work when we're dealing with graphing, right? If we're looking at x-intercepts, we can have something that crosses twice. If we're looking at those x-intercepts, there could be something that just touches once. Or there could be something that never crosses the x-axis. So we can have two solutions, we can have one solutions, and we can have no solutions. It's important that you do this. Make sure you get this down. Make sure you understand where these can all come from. They will show up more and more frequently as you continue on into algebra and into geometry and algebra 2. So that's all we have in terms of the lesson. Let's get you to some practice here. So here's some problems for you all to try out. Let's have you solve a couple of quadratics by graphing. Okay, so let's have you solve negative 2x squared is equal to negative 8, and x squared plus x minus 2 is equal to 0. So make sure you're going through and actually putting graphs for these. On the homework, you will not be getting points unless you have good graphs with labels, or not labels in this case, but with axes and tick marks to make me understand where exactly those are and what the graphs look like. Once you've done those, we'll have you solve a couple of quadratics algebraically. Let's have you solve 5x squared minus 125 is equal to 0. Let's have you do x squared plus 9 is equal to 0. So, pause the video right now, go ahead and practice each of these problems, and then we'll meet back up once you've finished those. Okay, welcome back. Let's get started with this first one. First thing we got to do is we want to make sure that one side is equal to 0. So we add 8 to both sides. Next step, we change that 0 into a y. So we get y is equal to negative 2x squared plus 8. And then we put this into our graphing calculators. So check this out. We get a point up here, and looks like we get something that looks roughly like that. What are our solutions then? Well, it's our x-intercepts. It's where this crosses the axes. So we get x is equal to positive 2 and x is equal to negative 2. Those are our solutions for this one. Let's look at this next one. First step, make sure it's equal to 0. We're already good, so we're going to change this into a y. Get y is equal to x squared plus x minus 2. Then we graph this. We get something that looks like, let's see, get an axis of symmetry here. And we should have values like that. So we get that our solutions are the x-intercepts, or we get that this is x is equal to -1 and x is equal to +2. Right, let's solve these algebraically. Remember, our first step is to isolate x squared. So want to do that by adding 125 to the other side. And we get that over. X squared isn't isolated. We have to get rid of this 5. So we're going to divide by 5. We get x squared is equal to 25. What's our next step? Take the square root. So we're going to take the square root. And square root of x squared is just x. Square root of 25, what number times itself makes 25? Well, it's not just +5. It's also -5. So we have those two solutions there. That's our answer for this one. And finally, looking at this last one, we isolate, so we subtract 9, we get x squared is equal to -9. Take the square root, so we get the square root of x squared is equal to the square root of -9. What number times itself makes -9? +3 times +3 makes 9. -3 times -3 makes 9. So we're looking for +3 and -3. But we can't do that, so there's no solution. All right, go ahead and do the homework.